All right, welcome to The Explainer. Today, we're diving into a story that is just wild. It spans 4 decades, you've got space shuttles, student scientists, and literally thousands of tiny astronauts. We're going to tackle a question that sounds kind of weird at first, but is actually super crucial for our future out there in the stars.
So, can bees actually survive in space? I mean, that's the big one, right? This question, as simple as it sounds, has been at the very heart of a 40-year scientific journey. And it's not just, for fun, it's a serious challenge that NASA has been wrestling with for decades. And as you're about to see, the answer is, well, it's way more complicated than you might think.
Okay, so the short answer is yes. Yes, they can. But, and this is a big but, it is so complicated. The story of how we figured this out is just filled with incredible trial and error, some amazing triumphs, and some really heartbreaking tragedy. To even get to that yes, scientists first had to figure out what they were really up against.
All right, first things first, to really get what a huge challenge this is, you have to try and imagine what a bee goes through the second it leaves Earth. Suddenly, gravity is just gone, and every single instinct it has for flying, for finding its way around, even for eating, it's all thrown into complete and utter chaos.
I mean, think about it. Without gravity, a bee's whole world is flipped upside down, literally. How do you fly when there's no up or down? Early astronauts saw them just sort of chaotically drifting, kicking their little feet instead of actually flying. They couldn't grip onto any smooth surfaces, they had a really hard time finding their food, and sometimes they just get stuck, tumbling over and over. For a creature that's perfectly designed for Earth's gravity, it's a completely disorienting, totally hostile new world.
So, let's talk about that first tragic flight. Our story really kicks off with this exact problem way back in 1982. The very first bees in space were on board the Space Shuttle Columbia. And what's so cool about this, what's really amazing, is that this whole groundbreaking experiment wasn't even designed by some top-tier NASA scientists. Nope, it was designed by a group of high school students. You can just imagine the excitement, right? This mission was filled with so much hope. It was a chance for these students to make history, and for scientists to see how bees might adapt to this new frontier. But the reality of microgravity? It was a brutal teacher. The 14 bees they sent up, they just couldn't fly. They spun, they drifted, and, tragically, every single one of them died before the shuttle even made it back to Earth.
But here's the thing. That failure, as tragic as it was not a waste. In fact, it provided the absolute most vital lessons for every single experiment that came after it. The researchers realized 2 crucial things. 1, in zero-G, food has to be super easy to get to because the bees can't fly in a controlled way to find it. And 2, you've got to give them textured surfaces, something rough they can grab onto to pull themselves around their home. It was a really hard lesson, for sure, but it was absolutely essential.
Okay, so now we get to the success story. After learning from that first failure, NASA decided to try again, just 2 years later. They totally redesigned the bee habitat based on those hard-learned lessons. They scaled up the whole experiment. And the results this time? They were nothing short of extraordinary.
Yeah, this time they didn't just send, a dozen bees. Check out this number, 3,300. On mission STS-41C in 1984, they sent an entire colony up, queen bee and all. The goal was way bigger now. Could a whole bee society actually function without the pull of gravity? And what they found out is just a brilliant illustration of how adaptable life can be. It's amazing. Within just a couple of days, the bees figured it out. They learned to navigate their new world, moving around with confidence. And here's the most incredible part. They built perfectly formed honeycomb. I mean, this is a complex architectural marvel, and they did it with zero gravity as a guide. The queen even laid 35 eggs. This mission proved without a doubt that these fundamental complex bee behaviors could continue, even in the most alien environment imaginable. So you might think, okay, great, success, end of story. But no. The success of that 1984 mission didn't end the story at all. It basically just opened up a whole new chapter. Researchers started asking new questions, this time about different kinds of bees, which led to decades more of experiments.
In this timeline, man, it really shows you what a long journey of perseverance this has been. You see it right there, from that first really difficult flight in '82 to the big success with the colony in '84, all the way up to 2018 when solitary bees made it to the International Space Station. But it also shows you the moments of real loss, like the heartbreaking 2003 Columbia disaster. A really promising experiment studying carpenter bees was lost on that mission, along with its heroic crew.
So that brings us to the big question. Why, right?
Why go through all this trouble, spend all this money, and take all these risks for bees? Well, the answer has everything to do with humanity's future on the moon, on Mars, and wherever we go next.
Look, if we're serious about long-term survival off-planet, we're going to have to grow our own food. It's that simple. And for so many of the fruits, vegetables, and seeds we absolutely rely on, well, that means we need pollinators. So this research, it isn't just about bees. It's about learning how to build these sustainable, closed-loop ecosystems that can actually support us as we venture farther and farther from home.
And this is what happens when you don't have pollinators. It's hilarious. During some experiments on the old Mir space station, an astronaut had to hand-pollinate the plants. And his solution, he made a bee stick. And it was literally a dried bee glued to a toothpick. I mean, it's an incredible example of astronaut ingenuity, for sure. But it's also this perfect, kind of funny symbol of just how essential these little creatures really are. So when you look back at this table, you can really see the entire 40-year story laid out right there. It's a journey that goes from that initial tough failure to stunning success, with every single mission building on the lessons learned from the one that came before it. So, in the end, the story of bees in space really isn't just about insects, is it? It's a powerful reminder that as we plan our future out there among the stars, we can't just pack our technology. To truly build a new home, it turns out we might just need to bring a small, buzzing, and absolutely essential piece of our old one right along with us.